Did you know that the next generation helicopters have greater performances than their predecessors? Ingenuity, which has been able to fly in Mars' harshest conditions. Its airspeed and high altitude flight has made it stand out and become the first ever helicopter to do so, but even the new helicopters have a lot more to offer. Before we go into understanding the new helicopters, let us first have a good knowledge on their predecessor functions. Let us take a quick pause to tap the like button as well and subscribe to our YouTube channel. Ingenuity, also referred to as Genie, is an automated helicopter, which is part of NASA's Mars 2020 mission. Although it is small, it was built to withstand the conditions of planet Mars and is currently in the operation. What makes this helicopter an outstanding one is its ability to fly on Mars, considering how Mars differs from Earth. Not only is Mars smaller in size, it is also a smaller mass. As a result, it has less density than that on Earth. Its gravitational force is 38% less of that of Earth, thereby having a weaker gravitational pull. It also has a much thinner atmosphere with the atmospheric pressure less than 1% of Earth's. It has capacities that can stand an atmosphere far less than that of the Earth. Ingenuity. This Ingenuity helicopter was not just developed all of a sudden, but involved a series of testing and updates. Ingenuity was aimed and designed to be a technology demonstrator before its building, launching, and landing. It was designed with the hope that helicopters could provide more mapping and guidance that would give future mission controllers more information to help with travel routes, planning, and hazard avoidances. Its development can be dated back to 2012 after members of the Autonomous System Division at Jet Propulsion Laboratory, or JPL, met with JPL Director Charles Ellicand. Considering the concept of the project, by January of 2015, NASA took up the funding of its full-size model, which was known as the Risk Reduction Vehicle, and Aerovent published the conceptual design for a scout helicopter to accompany a rover. When this project was approved as Mars 2020 program in July of 2014, a helicopter flight demonstration was neither scoped nor budgeted. Its development cost millions of dollars, as NASA spent about $80 million to build it and about $5 million to operate it. By December of 2017, engineering models of the vehicle were tested in a simulated Martian atmosphere. While the United States federal budget in March 2018 provided $23 million for the helicopter for 1 year, as it would enable it to be developed and tested in time in order to meet up in the Mars 2020 mission. The preliminary designs of Ingenuity were tested on Earth in 2019 in simulated Mars atmospheric and gravity conditions. To achieve flight testing in Mars conditions, a large vacuum chamber was used to enable for very low pressure filled with carbon dioxide to approximately 0.60% of the atmosphere of Mars. This condition is roughly equivalent to a helicopter flying at 34,000 meters or 112,000 feet altitude in the atmosphere of the Earth. For the much reduced gravity field of Mars, which is 38% of Earth's, 62% of Earth's gravity was offset by a line pulling upwards during flight tests. To provide wind in the chamber, a wind wall consisting of almost 900 computer fans was used. After the flight testing in 2019, the helicopter was named Ingenuity in 2020 by Venise Rupani, an 11th grade girl who submitted an essay into NASA's Name the Rover contest. The helicopter was later nicknamed Ginny, while the parent rover, Perseverance, is referred to as Percy. The helicopter, after undergoing extensive flight dynamics and environment testing, was mounted on the underside of the Perseverance rover. Percy is a rover with auto-nav capability that enables it to cover more than 100 meters per sol. The helicopter landed on February 18th of 2021 on the Martian surface, being attached to the underside of the Perseverance rover. On April 3rd, 2021, the helicopter was deployed to the surface, and both the rover and the helicopter began their missions at the Octavia E. Butler landing site on Mars. Later on, it made the first ever powered controlled extraterrestrial flight by an aircraft, where it took off vertically, hovered, flying for a total of 39.1 seconds, and then landed. But before the first flight, safety between Ingenuity and Perseverance was ensured as Percy drove approximately 100 meters or 330 feet away. During one of their operations, the sound of Ingenuity was recorded by Perseverance, making it the first time an in-situ interplanetary spacecraft recorded the sound from another interplanetary spacecraft. Its time of flight continued to improve as testing continued until it recently flew for 1 hour and 58 minutes and 48 seconds on its 66th flight. The flight shows that the helicopter is capable of flying in the very thin atmosphere of Mars, and the autonomous flight is also possible on other planets. And so Ingenuity must autonomously perform the maneuvers planned, scripted, and transmitted to it by its operators. After this spacecraft has proven its airworthiness, a series of flights to show how aerial scouting could aid the exploration of Mars and other worlds was commenced by JPL, where it scouted areas of interest for the Perseverance rover. Has the mission of Ingenuity been changed? We will find that out now, but don't forget to like our page and subscribe to our channel. Although the mission was Mars 2020, the aircraft's performance and resilience in the unfavorable Martian environment greatly exceeded expectations, and so the mission was extended. Its achievements, like surpassing its required altitude and flight duration specifications immediately after beginning operations on Mars, permitted it to perform far more flights than were initially expected. By November of 2023, the principal mission priorities were to avoid significant interference with rover operations, vehicle health and safety maintenance, scouting for a tactical planning and science assessment, and perform experiments to inform missions and vehicle design for future Mars rotorcraft, as well as collect data for dissectionary science. Successfully, the aircraft continues to perform successful flights, providing scientific data and site scouting to Perseverance. With such aerial scouting, it was assumed that future rovers would be able to safely drive up to the 3 times as far per Sol. Many wonder the components of this aircraft that gave it the capability to generate adequate lift in the Martian's harsh conditions of lower gravity, lower atmospheric density, and an altitude never reached by existing helicopters, 87,000 feet or 2,700 meters. This planet's atmospheric density decreases even more in Martian winter, but during Martian summer, lower air density imposed a higher load on the motors. As a result, flights were shifted from noon to morning and limited to 130 seconds to not overheat the motors. For every flight, the start time is chosen according to temperature management of the batteries, which need to be warmed up after the night. Ingenuity is a 0.49 meter or 1 foot and 7 inch tall vehicle that has a rectangular fuselage measuring at 136 millimeters by 195 millimeters by 163 millimeters. Again, 5.4 inches by 7.7 inches by 6.4 inches, suspended below a pair of coaxial counter-rotating rotors measured 1.21 meters or 4 feet in diameter. This assembly is supported by 4 landing legs of 384 meters, 15.1 inches each. It has a solar array of 425 by 165 millimeters, 6 solar cells with 35 to 40 watts, 130 to 140 kJ of energy capacity mounted above the rotors to recharge its batteries. Although Ingenuity is an aircraft, it has spacecraft specifications to endure the acceleration and vibrations during launch. To generate adequately in Mars, Ingenuity has specially shaped blades of enlarged size which must rotate between 2400 and 29 revolutions per minute, which would be about 10 times faster than what is needed on Earth. Separate swash plates control each of the helicopter's contra-rotating coaxial rotors that affect the collective and cyclic pitch. It also has 2 sensor assemblies, the upper sensory assembly and the lower sensor assembly. The upper sensor assembly, mounted close to the aircraft's center of mass on the mast, has vibration isolation elements that minimize the effects of angular rates and accelerations. The lower sensor assembly is mounted not on the mast but directly on the electronics core module, consists of an altimeter, cameras, and a secondary IMU. The cameras are 2 commercial off-the-shelf COTs, one is a high-resolution return-to-Earth RTE camera, and the other is a lower-resolution navigation nav camera which operates continuously all throughout every flight. The captured images are used for visual odometry to determine the aircraft's position and motion during flight. Unlike Perseverance, Ingenuity cannot take twin photos for 3D pictures simultaneously, but can generate 3D images by taking duplicate color photos of the same terrain while hovering in slightly offset positions. Alternatively, it can make such pictures by taking an offset picture on the return leg of a round-trip flight. For data transmission between the helicopter and rover, there is a telecommunications system which consists of 2 identical radios with monopoly antennas. The system relays data at 250 kilobits over distances of up to 1,000 meters or 3,300 feet. The number of images that can be saved from each flight is limited as a result of limitations on the transmission rate between the aircraft, the rover, and Earth. For the first time in the mission, on May 3rd and 4th, 2022, the helicopter surprisingly failed to communicate with the rover during one of its flights. This failure was determined by the JPL that Ingenuity's rechargeable batteries suffered a power drop or insufficient battery stage of chart (SOC), most likely because of a seasonal increase in atmospheric dust and lower temperature, thereby reducing sunshine on its solar panels. In order to prevent further occurrences of such, controllers decided to turn off the helicopter's heater at night to help conserve power. The helicopter later in January of 2023 began to have enough solar power due to the start of Martian spring, and this helps to avoid overnight burnouts of FPGA resets. As a result of this, the helicopter was able to fly more frequently and over longer distances. Some software like the flight control and navigation software of Ingenuity can be operated remotely. This remote control property has been used to correct software bugs and add new capabilities as the helicopter continues to operate beyond its original mission. For instance, before Flight 34, the software was updated to avoid hazards during landing and to correct a navigation error when traveling over uneven terrain because the helicopter traveled away from the flat terrain and flew towards more varied and hazardous terrain. While Ingenuity continues to break records of airspeed and high altitude, the idea of having prototypes that could exceed its performance has been proposed. The pair of new helicopters will have the features that will result in the vehicle running everything on its own instead of a fetch rover. The proposed prototype will have the ability to accurately follow the track it has already mapped on previously collected nav frame sets and land at the takeoff point. The development of future helicopters will be based on the data collected by Ingenuity and should be capable of carrying larger payloads. So from this, the blades of the new helicopter are slightly more than 10 centimeters long than the Ingenuity blades. The mission of the new Mars Helicopter 2030 will be sample collection, sample retrieval, and a return mission. Another thing about these next generation helicopters is that they are planned to have 4 wheels that will help facilitate sample analysis on Earth. With the wheels, they will drive to the sample upon landing a few meters from them. On retrieval, the helicopters will fly to the sample retrieval lander, which will load the samples into the Mars Ascent Vehicle (MAV), and then will launch the samples to low Martian orbit, where they will return to Earth for analysis. Anticipation on how the new Mars helicopters of greater performance will help improve science and engineering in years and decades to come has become the order of everyday life. Only time will tell. Subscribe and stay connected to our YouTube channel as we continue to bring you more updates on both Ingenuity and its prototypes.